In this short video, we will demonstrate how to engineer a distributed busbar protection 7SS85 sensor unit with DIGSI 5. We will do this by the example of a double busbar with 2 feeders and a coupler with 2 CTs. The communication topology will be HSR, and we will use the integrated master clock, a functionality which is available since the firmware version 9.20. My name is Rainer Goblasch, and I am the product lifecycle manager for all Siemens low impedance busbar protection devices. I will do this with my new colleague, Nina Hühn. Nina, it's up to you.
Thank you, Rainer. Hello and welcome also from my side. My name is Nina Hühn and I'm the promoter for differential protection. As Rainer already explained, we want to demonstrate the configuration of a 7SS85 distributed busbar protection with the help of a simple example. And this example looks like this. So we have a double busbar, 2 bays, 1 coupler with 2 CTs, 3 merging units, and 1 central unit, the SS85, where the grandmaster clock is integrated and running. So let's jump right in. I already prepared a new project in DIGSI. Here you can see nearly the same configuration as shown in the slide, but of course the missing parts we want to configure together. So here I already prepared 1 bay. This is here the typical bay in our case, and this serves also as copy master later on. And I already prepared the single line of the coupler bay with the 2 CTs. I've inserted 3 devices, so the 2 merging units are already configured, and the 7SS85 is also already created in this project. So in the next step, we want to complete the configuration of the first merging unit of the first bay. Then we want to copy the first bay to create the second bay. Then we take a look at all the configuration settings, and when all is finished, we do the process bus mapping and the communication mapping to finalize the configuration. Okay. So I start, as told, with the merging unit bay 01, and here we start with the communication settings. So in this case, I go to hardware and protocols. In this device, the port E is the one with the BD module that is mandatory for the process bus communication. With a double click on the module, I can open the settings for the network configuration. And here under the point protocols and communication, there are the IEC 61850 settings. And the protocol we want to use is the 9-2 merging unit 7SS85CU protocol. So
it's important to say that this 9-2 merging unit 7SS85CU protocol is really fully compliant to IEC 61850 It has only some extensions, both for binary signals and also some extension for easier engineering together with the 7SS85CU. But we will later see, we will create really fully compliant IEC 61850 somewhat measured value streams.
Point. I selected this protocol by just activating this checkbox. This always needs a small moment.
And background DIGSI 5 is doing a lot of things for us.
Okay, now the checkbox is activated and the configuration is finished. Then we check what else must be done here on the module side. As we saw in the example, we want to use for the sampled value synchronization the redundancy protocol HSR, and the time synchronization for the sampled value synchronization is IEEE 1588. So of course we also have to activate here this time sync protocol 1588 88 also by activating this checkbox.
Important to really to understand that here, by clicking this IEEE 1588, we do not activate the date and timestamp synchronization via IEEE 1588, but we only activating the sampled measured value synchronization via IEEE 1588. So this is sometimes mixed.
And we also check the settings for this. Now we are in the merging unit. The grandmaster clock is running in the central unit. So the merging unit is here only a slave in this case. So here this clock type setting is the correct one for the merging unit. So I just leave it like that. Okay. Now we do the same configuration for the 7SS85 concerning the network, the communication settings. So here I go also to hardware and protocols. In this case, the module BD module is in port F. Double click to open it. And under protocols and communication, I select here in this case for the central unit, the 9-2 CL7SS85CU communication protocol.
Yes, here I can do more or less the same remark as for the 9-2 merging unit functionality. We are now activating a fully compliant 9-2 client functionality in the 7SS85CU. We did only some extensions according to the binary signals and for easier engineering of a communication between Bay units, merging unit, and the 7SS85CU. But it's fully compliant to IEC 650.
Okay. So then I go to network and activate also the IEEE 1588. And go to the IEEE 1588 settings. And now we are in the central unit. So here the grandmaster clock should run. That means we are not in slave only mode. So I deactivate this checkbox and use the OC grandmaster capable function.
So now Nina has activated, as already said, the integrated grandmaster clock in the 7SS85. On principle, the grandmaster clock can be activated in each device in the HSR ring. But there's a specialty to enable it in the 7SS85 because the 7SS85 as a sender unit for the distributed busbar protection is the only device where this functionality is free of charge. Whereas in the merging unit, in the Bay units, you have to pay around about 100 function points for this functionality. So I give you the good advice to activate it in the 7SS85 instead of the merging units.
A good hint. And now I almost forget one point because we have also make the settings for the redundancy protocol. This is standardly set to line mode, and here we want to use the HSR mode. Of course, I have to do the same for the merging unit once again. So I change the protocols collection, confirm it with yes. Okay, and now we jump back to the merging unit and do the same. These are all the necessary settings for the communication protocols. So now we want to check the functions itself in the Bay unit. So if we take a look once again in the single line configuration, we see here for Bay 1, we have 2 disconnectors connected to the both bus bars, 1 circuit breaker, and 1 current transformer. So of course we have to make sure that all these elements shown here and physically there are also configured in the software. So I open the library Here we now in the merging unit device. I open the folder for the merging unit, and now I want to insert the two disconnectors. Disconnectors are switching devices, so I open this folder for switching the device, and then I will insert here this function disconnector status only. This is sufficient for our setup. So we are drag and drop on the settings of the merging unit. We just can insert this from the library. So make this twice. So we can see the circuit breakers already available, and the measuring point for the CT is already available. You can check this once. Short. So these routings are already done by default. So we have all the necessary elements here, and we are now finished for inserting the elements. But of course, maybe you want to insert some functionality from the library. This is of course also possible. For example, if we want to have the breaker failure protection or the end fault protection, we can insert this to the function group circuit breaker. So I once again go to the library, the merging unit, and here to the circuit breaker. And now I go here to the busbar function extensions, and then I see here the 15EF. This is the end fault protection function. Also via drag and drop, I can insert this functionality to the circuit breaker.
And Nina, don't forget also the circuit breaker failure protection.
Yes.
So we should demonstrate here all typically necessary backup protection functionality, which is common for distributed busbar protection, for busbar protection. So that's the inherent circuit breaker failure protection, and also the advanced circuit breaker failure protection. We should also demonstrate where to find.
Okay. So
at the end, you should add to your template. I think this first bay and bay unit is more or less the template to copy further all protection functionaries you need for your protection scheme.
Then we can really avoid this double work by just copying this master bay. Okay,
yes.
and
also you said you should route as much as possible all binary inputs, all binary outputs. You should adapt your settings. So in the copy of the next base, you will save a lot of time. Yep. So go on, Nina.
The additional circuit breaker function can be found here also in the function group circuit breaker in the folder circuit breaker failure protection. So now we have those three functions that we mentioned already inserted, and maybe there's also one other interesting thing, that is the bay out of service functionality.
Which is called now measuring point out of service, but thanks that you named it bay out of service, because most of the people know them still from the 7SS52, and in the 7SS52 we called it bay out of service. But as we now in our bay units have the possibility not only to cover the current of only one bay, of only one current transformer, now we are able in SIPROTEC 5 to cover up to 8 bays within one bay unit, and so we thought it would be a good idea to rename it from bay out of service really to measuring point out of service.
This function can be found also in the merging unit under measuring points, and here in current 3-phase also for this special busbar protection function, and here it is called measuring point out of service, and this must be drag and drop to the measuring point that we want to have this functionality.
This additional function is necessary when you want to start and stop the bay out of service, the measuring point out of service from the bay unit, from the merging unit. In the central unit, this functionality will automatically be possible. We will see it later.
And as Rainer mentioned, we now want to make some routings, at least the most important one, the routings for the disconnectors. The routing for the circuit breakers here per default already done. So we just add the routing for the two disconnectors that we inserted. So I just put the position from the disconnector 1 to the binary inputs 3 and 4. The open high and the close high command. And for the second disconnector, I use input 5 and 6. Okay. So these are the most important changes for the merging unit. Now I will come to the also most important changes for the central unit.
Of course, you should not forget also to adapt the settings of the current thresholds for the circuit breaker failure protection to route the start signal of the circuit breaker failure protection and also on. But I think it's fine for today. I think we want to demonstrate really the special things for distributed busbar protection.
So for the central unit, we only have to check in our case, in this minimum variant, I would say, that there are enough bus zones available in the device. So in our case, we have 2 buses and therefore we need 2 bus zones. So, and for now there are already 1 bus zone available, so we have to add a second one. Therefore I go to the library once again, but now to the
higher.
Yeah. Times hard to find. So now to the 7SS85 and to the function group busbar and to busbar protection function extensions, and here can be found the second bus zones. So I drag and drop this to the busbar protection. Okay, and these are all the settings changes we want to do for now. So as a next step, I want to make the connections in the single line diagram, so that we can see everything. Change the scale. Okay. And for the coupler bay, I did already the same things that we did together for the base 01. So here in this case, I can do the routings directly. So I start with the circuit breaker. Here we connect the measuring point of the circuit breaker to our measuring point in the bay 1. Connect the actual position of the circuit breaker to this status symbol of the circuit breaker. And I connect the 2 disconnectors to the disconnector elements. Okay. Then I do the same for the coupler bay. Here you have to choose one of the 2 measuring points for your circuit breaker. Then connect the circuit breaker status. Of course, also connect the 2 disconnectors in this case. And this is also all for the coupler bay. And for the central units, we have to connect the 2 bus zones to the 2 buses. Okay, now we really have finished our master bay, our copy bay. And yeah, that's what we want to do right now. We want to copy the first bay, and then we can see what really DIGSI is here capable of. It really saves us a lot of time. So I just, by using this rectangle function, I just select everything, right mouse click and copy. Click here somewhere else and paste it again. And then he's copying the single line diagram and the device as well. with all the setting changes that we've already made. Because this needs a small moment.
With already the activated protocols, which took a lot of time when we activated it, so it really saves also a lot of time. Oh, once again, you succeeded in copy the busbars. I do not know.
Yeah, we have to delete it and arrange it a little bit. That everything looks a little bit nicer. And we do the connections to the busbar. Use a name of in the same way as the first bay. And then we can take a small look on the newly created device. So here it makes also sense to rename it bay 02. And here also one small hint. It makes sense to go to the device information and check the IEC 61850 name, because when we see the routing later on in the system configurator, we can see that it is helpful to have here meaningful names that you can check the routings of the signals. So for the second bay, I call it merging unit underline bay 2. I already did the naming for the devices that are already in this project.
Did you already change the name of the 7SS85 also, the IEC name?
Yes, but okay. I can check again. Yes, I called it 7SS85.
So typically, I would recommend to use nearly the same name like the name, but unfortunately for the IC name, the first, you can't use a ticket as the first, how to say, on the first place of the name. It's not allowed to start with a ticket.
Then all the settings are made. So now we come to the most interesting point maybe for this small little video. We want to do the process bus routings connections. So as a first step, I go to once again to the single line diagram. And now we want to make the CU-BU assignment. Therefore, I change here the view from all devices to the 7SS85. And then he's automatically telling me that the CU-BU assignment must be updated. So that's what we want to do right now. So I confirm with yes.
Yeah, when the update CU-BU assignment is done, it's really a lot of engineering work done automatically. For each circuit breaker, disconnector, current transformer routed into single line editor, as Nina has done, to an element in the bay unit, this feature will create automatically proxy elements in the 7SS85 sender unit. We will create a proxy for each bay, and within this bay, we will create proxies for each disconnectors. We will create proxies for the position of the disconnectors. We will create proxies of the circuit breaker, the position of the circuit breaker, and also the most important signals about this protection functionalities here for the circuit breaker failure protection and the end-fault protection. A signal for the retrip, a signal for the trip T2, and so on. And very important, it will automatically be created a communication diagram between the elements in the bay unit and the associated elements in the sensor unit. And all this will be done within several minutes and saves really hours of fault-prone manually work. So now we are already finished. And Nina is already arranging now the measurement box, and how you will arrange this measurement box is here in the single line editor. You will see it later when you open the online monitoring of the busbar protection. So it's a good idea to arrange this here in a good way and will save a lot of time during commissioning. So it's up to you, Nina.
Okay, so I think this is nice enough for our case. So as a next step, we need to create a IEC 61850 station and really want to do all the communication connections, the process bus connections that fits here to the project and to the configuration we made. So I go to the folder IEC 61850 station. There's at the moment no station available, so I add a new station by double click. And with double click, I open the newly created station. And now we see the 4 devices that we created. And with this double arrow, I can assign all these 4 devices to the IEC station that we created. And now we export the settings to the IEC 61 configurator, system configurator. And therefore I use this export button.
Needs once again a little bit of time, depending also on the size of your substation and the number of devices you have created.
Okay, now he needs a folder where we save this station. And yeah, now he's really exporting all the information to the system configurator. So the system configurator opens automatically. Okay, now we see here this orange warning. This is there because we can see here under network and the default subnet that all the devices in this subnet, all our 4 devices have at the moment the same IP addresses. This of course is not so nice. It's not a problem for our configuration, but just to remove here this warning, I do a right mouse click on the default subnet and use the option automatic addressing. Overwrite the existing IP addresses, and then they have individual IP addresses.
As Nina said, this is not really necessary for the functionality to transmit the standard measured values, because for this purpose, we will create automatically MAC addresses. These IP addresses will only be necessary to have access via DIGSI 5 via network to the different devices, but it's not necessary for the distributed busbar protection. But we want to get rid of any inconsistency in the system configurator, so it's absolutely fine.
Okay, and then we go to the sampled values. And here, by right mouse click on the IEC station, there's the option sample measured values mapping through topology. And this is the option I select now. Now he automatically connects the sampled measured values from the base to the central unit according to the single line and to the configuration we made in DIGSI.
So maybe just to open one, to demonstrate and to show it. And here we can also see where the IEC name we have changed. You will see here this merging unit MU Bay 01 is exactly the IEC name we have given to the device. The same like here in the destination, the 7SS85, which is also the IEC name, which is displayed here in the IEC configurator.
And that's already all we have to make here. So I save the changes and close the system configurator. And now, as nearly the last step, I re-import the changes from the system configurator to DIGSI. There's also this import button. He just warns me that maybe some current voltage transformer settings may have changed. This is okay for us in this case.
So hopefully we worked fine, and the inconsistency will be deleted.
Drum roll.
But I'm quite sure.
It looks good. So maybe let's have a look what happens. I go to the information routing of the central unit. And now we can see here under the power system that we now have the proxy elements of the measuring points of the bay units here, for 3. And
maybe show also the signal for the bay out of service.
So just open one of those, and here it is. This down there, and here are the signals messages for the measuring point out of service functionality. And
okay. Yeah, exactly. I go to the base, and here we will see also the bay out of measuring point of service directly from the central unit. I think it's below general. Yeah, yes, exactly. Yeah, and here see, so that's automatically from the to start the bay out of service, the measuring point out of service from the central unit, you will have it automatically under the general of the bay proxy in the central unit.
And yeah, we see for all the functions we created and for all the 3 elements, there are now here these proxy elements with the signals visible in the information routing. So maybe just
maybe open the circuit breaker will be interesting with the circuit breaker failure protection and the end-fault protection.
So here, for example, the breaker failure protection and T1, T2 trip, for example. So these signals are now automatically created and available in the central unit. Maybe we also look at the merging unit, and there I go to the merging unit routing. And now we see here that the stream type, the stream is now connected of the measuring point here in this case. The stream type, maybe we can have a short look on the stream type settings.
And here we can say what I have said. Really, this 9-2 merging unit functionality for 7SS85 CU is really using fully IEC 650 compliant process bus streams. And, in this process bus stream, we are using the fixed sampling rate of 4000 Hz and 1 ASTU. This can't be changed, so that's the best sampled measured value stream for distributed busbar protection, but this stream can be used without any problems by different clients if necessary. So then you have to do it manually in the IC configurator, but it's without problems possible also to use this stream for other applications in other devices.
So now
maybe one we forgot maybe to show in the power system of the 7SS85 the routing we have done to remove the inconsistency. I think that will be, from my point of view, the last thing we should maybe show to.
So that these are now available, these elements, or where do we want to?
Oh, sorry, not in the power system, in the measuring points routing. I give you the wrong hint. Yeah, so here we see the 3 proxies of our measuring points which have been created, and you see here that all these measuring points come via the process bus client. And if we go now to the properties, we will see also where they exactly came from. Yeah. So more or less the same we have seen in the IEC configurator.
Okay. Yeah, then now we are finished with the configuration. Now you just have to load it to the device and can start testing. We hope this video was interesting for you and helpful. And thank you for your attention.
Yeah, thank you, Nina, for the nice demonstration. I also have to thank for your attention, and Nina and me, we hope that this video will help you to configure your first distributed busbar protection. Goodbye.
Goodbye.